Now, in this lecture, we will find out the values of line segments X and Y. In the drawing, we have a square DEBF. We know that DB equals to 1 unit, BF equals to 1 unit, and we also know that all the sides of a square are equal to each other. Therefore, EF will be also equal to 1, and DE will be also equal to 1. So this square is inside a right triangle, the right triangle ABC. We know that the hypotenuse of the right triangle ABC, the hypotenuse AC equals to 3 units. And we want to find out the values of line segment FC that is actually equals to X, and the value of line segment AD that is actually equals to Y, according to what is given us in the question. So we'll start with the rule that the opposite sides of a square are parallel to each other. That is to say, DE is parallel to BF. DE is parallel to BF because of the fact that the opposite sides of a square are parallel to each other. And BC is one side of the right triangle, triangle ABC. Therefore, BC is absolutely a straight line. BC is a side of a triangle, it must be a straight line. So we write down that BC is a straight line. But as you see from the drawing, you can see that BF is part of the straight line BC. And we know that BC is parallel to DE. So if a part of a straight line is parallel to another straight line, then the straight line itself will be also parallel to that straight line. And we know that BF, that is part of BC, is parallel to DE. Therefore, the straight line BC will be parallel to DE. So we can write down that BC is also parallel to DE. I repeat again, because of the fact that a part of the straight line is parallel to DE, then the straight line itself, that is BC, will be also parallel to DE. Therefore, BC is parallel to DE. And we also have rule number 1. According to rule number 1, corresponding angles between parallel lines are equal to each other. I write it down. Corresponding angles between parallel lines are equal to each other. I will read rule number 1 again. According to rule number 1, corresponding angles between parallel lines are equal to each other. So we actually can implement rule number 1 in our drawing because of the fact that we know that those two angles are defined as corresponding angles. Angle AED and angle ECF are defined as corresponding angles, and they are located between the parallel lines DE and BC. Therefore, they are equal to each other according to rule number 1. So we can write down that angle AED, this angle, is equal to angle ECF, this angle, according to rule number 1, that states that corresponding angles, that is to say those two angles are defined as corresponding angles if two corresponding angles are located between parallel lines, then they are equal to each other. And indeed, those two corresponding angles are located between the parallel lines DE and BC. We proved that DE is parallel to BC, therefore they are equal to each other. So I repeat again. Angle AED equals to angle ECF according to rule number 1. And if we define angle AED as theta, so if angle AED is equal to theta, then from this equation we derive that angle ECF also equals to theta. So angle ECF will be also equal to theta. So we found out that those two angles are equal to each other and they are both equal to theta according to our definition. In the next step I will present to you a new rule, rule number 2. According to rule number 2, the sum of the angles on one side of a straight line is equal to 180 degrees. I will write it down. The sum of the angles on one side of a straight line is equal to 180 degrees. I will read rule number 1 again. According to rule number 2, I will read rule number 2 again. According to rule number 2, the sum of the angles on one side of a straight line is equal to 180 degrees. And we can also implement rule number 2 in our drawing. AB, side AB is one side of triangle ABC, therefore it is absolutely a straight line. So AB is a straight line. And if we focus on this side of the straight line AB at point D, then the sum of the angles at point D, at this side of the straight line AB, must be equal to 180 degrees. So if we define angle ADE as x, then x plus 90 degrees must be equal to 180 degrees according to rule number 2. X plus 90 degrees must be equal to 180 degrees according to rule number 2. Here we will subtract 90 degrees from this equation, and we will get that angle x equals to 180 degrees minus 90 degrees. That is to say, it equals to 90 degrees. So we found out that angle x is a right angle. It equals to 90 degrees. So we will substitute angle x by a right angle. Likewise, BC is a straight line because of the fact that it's one side of the right triangle, triangle ABC. BC is a straight line. So if we focus on the upper side of the straight line BC at point F, then the sum of the angles on the upper side of the straight line BC at point F must be equal to 180 degrees according to rule number 2. So if we define angle EFC as Y, then according to rule number 2, we will get that y plus 90 degrees must be equal to 180 degrees. So I will write it down. And the size of angle y plus 90 degrees must be equal to 180 degrees according to rule number 2. So here we will subtract 90 degrees from this equation, and we will get that angle y equals to 180 degrees minus 90 degrees, that is to say it equals to 90 degrees. So we found out that angle y is a right angle, it equals to 90 degrees, so I will substitute angle y by a right angle. So if angle EFC, that is angle y equals to 90 degrees, then it means that triangle EFC is a right triangle, and also because of the fact that angle ADE equals to 90 degrees, triangle ADE is a right triangle, and it also given us in the question that the big triangle, triangle ABC, it is also a right triangle because of the fact that angle ABC equals to 90 degrees. Okay, so we will focus on the right triangle, triangle ADE. On the right triangle, triangle ADE, we know that tangents theta equals to AD over DE. I will repeat again. On the right triangle, triangle ADE, we know that tangent theta equals to AD over DE. Here AD equals to y according to what is given us in the question. and DE equals to 1 unit because of the fact that all the sides of a square DEBF are equal to 1 unit. So DE equals to 1. So in conclusion, we actually found out that according to equation number 1, tangent theta equals to y. I repeat again. According to equation number 1, we found out that tangent theta equals to y. In the next step, we will focus on the right triangle, triangle EFC. On the right triangle, triangle EFC, tangent theta equals to EF over FC. I'll repeat again. On the right triangle, triangle EFC, tangent theta equals to EF over FC. But EF equals to 1 unit because if it is one side of the square, so it equals to 1 unit, and FC equals to x according to what is given us in the question. So in conclusion, we found out that according to equation number 2, tangent theta equals to 1 over x. I repeat again, tangent theta according to equation number 2 equals to 1 over x. In the next step, we will create equation number 3 that states that tangent theta according to equation number 1 must be equal to tangent theta according to equation number 2. Okay, so equation number 3 states that tangent theta according to equation number 1 that is equal to y must be equal to tangent theta according to equation number 2, and according to equation number 2, tangent theta equals to 1 over x. So we actually found out that according to equation number 3, y equals to 1 over x. What does it mean? It means that y is the inverse numbers of x. And if we multiply equation number 3 by x, we will get that x times y equals to 1. And we actually can write down that y is the inverse number of x, and it is also true to say that x is the inverse number of y. Why? Because if we divide equation number 3, xy equals to 1 by y, we will get that x equals to 1 over y. So x is the inverse number of y. And it is also very important to emphasize that every number every number has only one inverse number. For example, the inverse number of 5 is 1 over 5, and the inverse number of 1 over 5 is 5. Okay? So the only inverse number of 5 is 1 over 5, and the only inverse number of 1 over 5 is 5. Okay? Every number has only one inverse number, and when you multiply the number with its inverse number, you will always get 1. 5 times 1 over 5 will give us 1. Okay? In the next step, we will focus on the right triangle, triangle ABC. In the right triangle, triangle ABC, according to the Pythagoras theorem, here PT is the abbreviation for Pythagoras theorem. According to the Pythagoras theorem, the square of the hypotenuse in any right triangle, and especially in the right triangle ABC, equals to the square of the hypotenuse equals to the sum of the squares of the perpendiculars. And the hypotenuse in the right triangle, triangle ABC, is AC. The square of the hypotenuse is AC squared. AC squared must be equal to AB squared plus BC squared. I will repeat again. In the right triangle, triangle ABC, according to the Pythagoras theorem that the square of the hypotenuse equals to the sum of the squares of the perpendiculars, we get that AC squared equals to AB squared plus BC squared. This is actually equation number 4. AC equals to 3. Therefore, AC squared will be equal to 3 squared. 3 squared is 9. And it equals to AB squared. AB equals to y plus 1. Therefore, AB squared will be equal to y plus 1 squared plus BC squared. BC equals to x plus 1. Therefore, BC squared will be equal to x plus 1 squared. So, in conclusion, according to equation number 4, we got that 9 equals to y plus 1 square plus x plus 1 square. So here we will open the brackets in this side of equation number 4, and we will get that y plus 1 square equals to y square plus 2y plus 1 plus x plus 1 square equals to x square plus 2x plus 1, and it equals to 9. Okay? But according to equation number 3, we have already found out that y equals to 1 over x. That is to say, we can substitute y in equation number 4 by 1 over x. So we'll do it now, and we will get that according to equation number 4, y is 1 over x. So y squared is 1 over x squared. plus 2y. 2y is 2 times 1 over x plus 1 plus x squared plus 2x plus 1 equals to 9. Here we will organize the expression in a different way, and we will get that x squared plus 1 over x squared plus 1 plus 1 is 2, so plus 2 plus 2x plus 2 times 1 over x equals to 9. So inside the brackets we have x squared plus 1 over x squared plus 2. As you already know, this expression equals to x plus 1 over x squared plus, here we will take 2 as a common factor from these two expressions, and we will get that 2 inside the brackets we will have here x, and from this expression we will have 1 over x, and we will subtract 9 from this equation equals to 0. Here we will define t as x plus 1 over x. That is to say, according to our definition, t equals to x plus 1 over x. Therefore, we can substitute x plus 1x by t. In the question number 4, we will do it now, and we will get that x plus 1 x squared will be equal to t squared plus 2 times x plus 1x is 2 times t minus 9 equals to 0. So we got here quadratic equation. The variable in this quadratic equation is t, and the general formula for a quadratic equation is ax squared plus bx plus c equals to 0. Here a, b, and c are the coefficients of this quadratic equation, and x is the variable that we are looking for, and we will find out the value of x according to a special formula for x. X equals to minus b plus minus square root of b squared minus 4 times a times c over 2 times a. Okay, and in our specific quadratic equation t squared plus 2t plus 9 equals to 0, the variable that we are looking for is t, so we can write down that x equals to t, and we will find out the value of t according to the special quadratic equation for x that in our specific case is equal to t, and the coefficients of our specific quadratic equation are as follows. T equals a equals to 1, b equals to 2, and c equals to minus 9. So we want to find out the value of the values of t. In order to find out the value of t, we will put the data inside the equation for x that in our specific case is t, and we will get that t that equals to x equals to minus b equals to 2, so minus b is minus 2, plus minus square root of b squared. B equals to 2, so b squared is 2 squared, 2 squared is 4, minus 4 times a is 1, c is 9, so it is minus 4 times minus 9 over 2. 2a is 2 times 1, because a equals to 1, so 2 times 1 is 2. So we actually got that t equals to minus 2 plus minus square root of minus 4 times minus 9 is plus 36, and 4 plus 36 is 40. So inside the brackets we left only with 40, all divided by 2. So t equals to minus 2 plus minus, and we know that 4d is 4 times 10, and the square root of 4 is 2, so we write down here that square root of 40 is actually 2 times square root of 10, all divided by 2. Here t equals to minus 2 over 2 is minus 1, and plus minus 2 over 2 is 1. So in conclusion, we found out that t equals to minus 1 plus minus square root of 10. Okay, and here we have two solutions that are possible for t. The first solution is t equals to minus 1 plus square root of 10, and the second solution for t is t equals to minus 1 minus square root of 10 and according to our definition, t equals to x plus 1 over x, and it equals here to minus 1 minus square root of 10. But as you can see from the drawing, x is the length of one side of the right triangle, triangle EFC. Therefore, x as a length must be a positive number. If x is positive, then x plus 1 over x must be also a positive number. And according to the second solution, the positive number equals to minus 1 minus square root of 10. But minus 1 minus square root of 10 is a negative number. So we got here to a contradiction. A positive number can never be equal to a negative number. Therefore, this solution is incorrect solution. We will cancel this solution, and we left only with the solution that t equals to minus 1 but plus square root of 10. According to our definition, t equals to x plus 1 over x, and it equals to minus 1 plus square root of 10, the positive square root of 10, of course, because the negative is incorrect. So here we will multiply x by x and then we will divide it by x in order to have a common factor with 1 over x, and we will get that x times x is x squared plus 1 over x equals to square root of 10 minus 1. Here we will multiply this equation by x and we will get that x squared plus 1 equals to square root of 10 minus 1 times x. Here we will subtract from this equation square root of 10 minus 1 times x, and we will get that we have actually here a quadratic equation. Then the quadratic equation is x squared minus square root of 10 minus 1 times x plus 1 equals to 0. Okay, and the solution to the quadratic equation is x equals to minus b plus minus square root of b squared minus 4 times a times c over 2a. Okay, and in our specific equation, quadratic equation, we know that a equals to 1, the coefficient a equals to 1, the coefficient b equals to minus square root of 10 minus 1, and c equals to 1. So we will put the data inside the equation, the formula for x, and we will find out the value of the values of x of this quadratic equation. It might be that we will find out two solutions for x. Okay? So, according to the formula for x, we will get that x equals to minus b, b equals to minus square root of 10 minus 1. Minus and minus is plus, so we'll get here that b equals to square root of 10 minus 1 plus minus b squared. B squared will be equal to square root of 10 minus 1 squared minus 4 times a times c. A equals to 1, c equals to 1. So minus 4 times a times c equals to minus 4, all divided by 2a. A equals to 1, so 2 times 1 is 2. So it is divided by 2. So we got here that x equals to square root of 10 minus 1 plus minus, and inside the root we have square root of 10 minus 1 squared. It is actually a minus b squared. It is a squared, that is to say square root of 10 squared, that is 10, plus b squared, it is 1 squared, that is 1 plus 1, minus 2 times ab, minus 2 times square root of 10 times 1. And we, okay? And we also have to subtract minus 4 times ac. So it is minus 4 times a is 1, c is 1, so it is minus 4. All divided by 2a, that is 2, because a equals to 1. So we got here that x equals to square root of 10 minus 1 plus minus. Inside the root we have 10 plus 1 is 11, 11 minus 4 is 7, minus 2 times square root of 10, all divided by 2. So we have here two solutions that are possible, but before that we will find out the value of 7, the value of the expression that is inside the root, that is actually 7 minus 2 times square root of 10. What is the value of 7 minus 2 times square root of 10? The value of 7 minus 2 times square root of 10, here 7 is 5 plus 2, so we'll substitute 7 by 5 plus 2, minus 2 times square root of 10. And we will substitute square root of 10 by square root of 5 times square root of 2. So we also know that 5, it is actually square root of 5 square, and 2 is square root of 2 square, minus 2 times square root of 5 times square root of 2. This expression, square root of 5 square plus square root of 2 square minus 2 times square root of 2 times square root of 5, is very similar to the algebraic identity that states that a square plus b square minus 2 times ab equals to a minus b square. That is to say, we can substitute our expression by a minus b square when a equals to square root of 5 and b equals to square root of 2. So we'll do it now, and we will get that our expression is equal to a minus b square. A is square root of 5, b is square root of 2, so it is minus square root of 2 squared. So we actually found out that the original expression 7 minus 2 times square root of 10 equals to square root of 5 minus square root of 2 squared. Now we will return to our original expression, and we will put inside the root, instead of 7 minus 2 times square root of 10, we will put square root of 5 minus square root of 2 squared. Okay? And we will get that here, this is our original expression. We got that actually x equals to square root of 10 minus 1 plus minus, and we have inside the root 7 minus 2 times square root of 10, and according to our calculations we found out that 7 minus 2 times square root of 10 equals to square root of 5 minus square root of 2 squared, so we'll substitute 7 minus 2 times square root of 10 by square root of 5 minus square root of 2 squared, all divided by 2. So x equals to square root of 10 minus 1 plus minus, it is divided by 2 of course, here inside the root we have a square, therefore the square cancels the root and we left only with square root of 5 minus square root of 2. So I write it down. The root is cancelled by the square, and we left only with square root of 5 minus square root of 2. And we have here two solutions that are possible. We'll define the first solution as x1, and the second solution will be defined as x2. So we'll start with the first solution, that is actually x1 equals to square root of 10 minus 1 plus square root of 5 minus square root of 2. This is the first solution, all divided by 2, of course. And the second solution is x2. The second solution, x2, is actually equals to square root of 10 minus 1 minus x1 is plus and x2 is minus. Okay, it is minus square root of 5 minus square root of 2 all divided by 2. So we will continue with x1, and we will get that x1 equals to square root of 10 minus 1 plus square root of 5 minus square root of 2 all divided by 2. Here we will substitute square root of 10 by square root of 5 times square root of 2, because square root of 5 times square root of 2 equals to square root of 10. So it is minus 1 plus square root of 5 minus square root of 2 all divided by 2. So we get that actually that here we took square root of 5 as a common factor out of this expression, and we get that x1 equals to square root of 5 is a common factor. And inside the brackets we will have square root of 2 plus 1, and we will take minus 1 as a common factor from minus 1 and from minus square root of 2. So minus 1 is a common factor, and inside the brackets we will have 1 plus square root of 2 all divided by 2. So here we will take square root of 2 plus 1 as a common factor, and we will get that x1 equals to square root of 2 plus 1 is a common factor. And inside the brackets we will have square root of 5 minus 1 all divided by 2. So actually we found out that x1 equals to square root of 2 plus 1 times square root of 5 minus 1 over 2. We will do the same process for x2, and we will get that x2 equals to square root of 10 is square root of 5 times square root of 2 minus 1 minus square root of 5, minus and minus is plus, so it is plus square root of 2 all divided by 2. Here we'll take square root of 2 as square root of 5 as a common factor, and we will get that x2 equals to square root of 2 was taken as a common factor. Inside the brackets we will have square root of 2 minus 1 plus square root of 2 minus 1 all divided by 2. Here we will take square root of 2 minus 1 as a common factor out of this expression, and we will get that x2 equals to square root of 2 minus 1 was taken as a common factor, and inside the brackets we will have square root of 5 plus 1, all divided by 2. So we actually found out that x2 equals to square root of 2 minus 1 times square root of 5 plus 1, all divided by 2. And x1 equals to square root of 2 plus 1 times square root of 5 minus 1, all divided by 2. And in the next step, we will multiply x1 by x2. So first of all, I will copy the two solutions for x to the new page, and we actually found out that x1 equals to square root of 2 plus 1 times square root of 5 minus 1, all divided by 2. And we also found out that x2 equals to square root of 2 minus 1 times square root of 5 plus 1, all divided by 2. So those are the two expressions for x1 and x2. As I've already said, we will multiply x1 by x2, and we will get that x1 times x2 will be equal to square root of 2 plus 1 times square root of 5 minus 1, all divided by 2. And it is multiplied by x2, that is actually square root of 2 minus 1 times square root of 5 plus 1, all divided by 2. So here we will organize the expressions of x1 and x2 in a different way, and we'll get that x1 times x2 equals to square root of 2 plus 1 times square root of 2 minus 1 times square root of 5 plus 1 times square root of 5 minus 1, all divided by 2 plus 2, 2 times 2, 2 times 2 is 4. So here we have square root of 2 plus 1 times square root of 2 minus 1, and we also have square root of 5 plus 1 times square root of 5 minus 1. We'll calculate the value of the multiplication of those two expressions by the algebraic identity that states that a plus b times a minus b equals to a squared minus b squared. And so we'll calculate the value of square root of 2 plus 1 times square root of 2 minus 1. It must be equal to a squared minus b squared. Okay? And here a equals to square root of 2. And b equals to 1. So we must get that this expression equals to a squared minus b squared. A is square root of 2, so a squared is square root of 2 squared. Square root of 2 squared is 2 minus b squared. B equals to 1. So b squared is 1 squared. 1 squared is 1. So it is minus 1. So in conclusion, we found out that square root of 2 plus 1 times square root of 2 minus 1 equals to 2 minus 1. That is actually 1. And then we have to find out the value of square root of 5 plus 1 times square root of 5 minus 1. And we know that this expression must be equal, it is very similar to a plus b times a minus b, so it must be equal to a squared minus b squared. And in our specific expression, a equals to square root of 5, and b equals to 1. So, and we must get a squared minus b squared. A equals to square root of 5. So a squared is square root of 5 squared. Square root of 5 squared is 5 minus b squared minus b equals to 1. B squared is 1 squared. 1 squared is 1. So in conclusion, we found out the square root of 5 plus 1 times square root of 5 minus 1 is 5 minus 1. And we have to divide it by 4 because in the denominator we have 4. So we actually found out that x1 times x2 equals to 2 minus 1 is 1, 5 minus 1 is 4, all divided by 4. 1 times 4 is 4, and 4 over 4 is 1. So we actually found out that x1 times x2 equals to 1. Okay? And as you remember, when the multiplication of two numbers is equals to 1, it means that 1 is the inverse number of the other. So we can write down here, because of the fact that x1 times x2 is equal to 1, it means that x1 is the inverse number of x2, and it is also true to say that x2 is the inverse number of x1. Okay? Because of the fact that x1 times x2 equals to 1, it means that x1 is the inverse number of x2, and also x2 is the inverse number of x1. But according to equation number 3, we have already found out that x times y also equals to 1. Therefore, it means that x is the inverse number of y, and y is the inverse number of x. Exactly as we did here. It's the same rule we have here. So x and y are two inverse numbers, each is the inverse number of the other, and we have two solutions for x. So we define the first solution as x1 and y1, and the second solution will be defined as x2 and y2. And we will put the solution inside equation number 3, and we will get that x equals to x1, so it is x1, and y equals to y1, so it is times y1 equals to 1. So we found out that x1 times y1 equals to 1. What does it mean? It means that y1 is the inverse number of x1, but we have already found out that x2 is the inverse number of x1. And as I have already told you, every number has only one inverse number. It is impossible that two different numbers will be the inverse numbers of a specific number. Okay? But we found out that y1 is the inverse number of x1, and x2 is also the inverse number of x1. But we have only one inverse number of each number. x1 has only one inverse number. And because of the fact that x1 has only one inverse number, it means that y1 equals to x2. Okay, y1 equals to x2. Okay. And we'll do the same process for the second solution. The second solution is x2 times y2 equals to 1 according to equation number 3. We put the values of x equals to x2 and y equals to y2, and we found out that x2 times y2 equals to 1. What does it mean? It means that y2 is the inverse number of x2. But we have already found out that x1 is the inverse number of x2. And it is impossible that we have two different numbers that are the inverse numbers for a specific number. x2, it is a specific number, and it has only one inverse number. And because of the fact that x2 has only one inverse number, it means that y2 equals to x1. Okay, so in conclusion, we found out that y2 equals to x1 and y1 equals to x2. Okay, so now it is very easy to display the solutions for the question, to write down the solutions for the question. The first solution for x and y is x1 and y1, and we have already found out that x1 equals to square root of 2 plus 1 times square root of 5 minus 1 over 2. This is the value of x1. And y1, we have already found out that y1 equals to x2. So here we write down that the value of x2, that is actually y1, and x2, it is actually square root of 2 minus 1 times square root of 5 plus 1, all divided by 2. So this is the first solution. x1 equals to square root of 2 plus 1 times square root of 2 minus 1 over 2, and y1 equals to square root of 2 minus 1 times square root of 5 plus 1 over 2. And the second solution to the question is x2, y2, and we have already found out that x2 equals to square root of 2 minus 1 times square root of 5 plus 1, all divided by 2, and y2, we have already found out that y2 equals to x1. So y2 equals to x1, that is to say, it equals to square root of 2 minus 1 times square root of 5 plus 1, all divided by 2. Okay, so actually this is the two solutions for x and y, x1, y1, and x2, y2. And that is the answer to the question. In the next step, I will summarize the lecture. So we have here square DEBF. We know that one side of this square equals to 1 unit. The square is inside the right triangle ABC. We know that the hypotenuse AC of the right triangle equals to 3 units. And we want to find out the value of line segment FC, that is x, and the value of line segment AD, that is y. So first of all, we have the rule that the opposite sides of a square are parallel to each other. That is to say, DE is parallel to BF. DE is parallel to BF. And we know that BC is one side of the right triangle ABC. So BC is a side of a triangle. It must be a straight line. Okay, so BC must be a straight line, and BF is part of BC. BF is part of BC and is parallel to DE. So we know that part of the straight line BC is parallel to DE, therefore the straight line itself BC must be also parallel to DE. Okay, so we arrive to the conclusion that BC is also parallel to DE, because of the fact that if part of a straight line is parallel to another straight line, then the straight line itself must be also parallel to the straight line. Then I presented to you rule number 1. According to rule number 1, corresponding angles between parallel lines are equal to each other. So here, those two angles are defined as corresponding angles, and they are located between the parallel lines DE and BC. That is to say, we've already found out that DE is parallel to BC. So those two angles are located between the parallel lines DE and BC. Therefore, they are equal to each other according to rule number 1. That is to say, angle AED equals to angle ECF according to rule number 1. Why? Because those two corresponding angles are located between parallel lines, therefore they are equal to each other according to rule number 1. And if we define this angle as theta, then according to this equation we will conclude that ECF also equals to theta. This angle also equals to theta. So we found out that those two angles, they are equal to each other, and they are both equal to theta. Then I presented to you rule number 2. According to rule number 2, the sum of the angles on one side of a straight line is equal to 180 degrees. And we can implement rule number 2 in our drawing. AB is one side of the right triangle, triangle ABC. Therefore, it is absolutely a straight line. So we can write down that AB is a straight line. And if we focus on this side of the straight line AB at point D, then according to rule number 2, the sum of the angles on this side of the straight line AB at point D must be equal to 180 degrees. So this angle equals to 90 degrees, plus this angle that we define as angle X must be equal to 180 degrees. Again, angle X plus 90 degrees must be equal to 180 degrees according to rule number 2. We subtracted 90 degrees from this equation, and we found out that angle X equals to 180 degrees minus 90 degrees is 90 degrees. So angle X, this angle, is a right angle, therefore triangle DE is a right triangle. And likewise, BC is one side of the right triangle, triangle ABC, therefore it is absolutely a straight line. BC is a straight line, and if we focus on the upper side of the straight line BC at point F, the sum of the angles must be equal to 180 degrees according to rule number 2. Which angles we have here? We have here 90 degrees plus this angle that we will define as angle Y. In total, the sum of those two angles must be equal to 180 degrees according to rule number 2. Again, Y plus 90 degrees must be equal to 180 degrees. We subtracted 90 degrees from this equation, and we found out that angle Y equals to 180 degrees minus 90 degrees. That is to say, angle Y equals to 90 degrees. Okay, this angle equals to 90 degrees. Therefore, triangle EFC is also a right triangle. Then we focused on the right triangle, triangle ADE. On the right triangle, triangle ADE, you can see that tangent theta equals to AD over DE. Again, in the right triangle, triangle ADE, tangent theta equals to AD over DE, but AD equals to Y, according to what is given as the question, and DE equals to 1. Okay, so in conclusion, we found out that tangent theta equals to Y, according to equation number 1. Then we focused on the right triangle, triangle EFC. On this triangle, tangent theta equals to EF over FC. On triangle EFC, tangent theta equals to EF over FC, but EF equals to 1, FC equals to X. So in conclusion, we found out that according to equation number 2, tangent theta equals to 1 over X. Then we created equation number 3 that states that tangent theta according to equation number 1 must be equal to tangent theta according to equation number 2. That is to say, according to equation number 3, tangent theta according to equation number 1 that equals to Y must be equal to tangent theta according to equation number 2 that equals to 1 over X. That is to say, according to equation number 1, we found out that Y equals to 1 over X. What does it mean? It means that Y is the inverse numbers of X, and we multiplied equation number 3 by X, and we found out that X times Y equals to 1. When the multiplication of two numbers is equals to 1, it means that 1 is the opposite, is the inverse number of the other. So we can write down that Y is the inverse number of X, and X is the inverse number of Y. And it is very important to remember that every number has only one inverse number. 5 has only one inverse number, that is 1 over 5. And 1 over 5 has only one inverse number, that is 5. Okay? Then we focused on the right triangle, triangle ABC. According to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, the hypotenuse is AC, and the square of the hypotenuse is AC squared. and it equals to AB squared plus BC squared. Again, according to equation number 4, AC squared equals to AB squared plus BC squared. AC equals to 3, so AC squared is 3 squared, 3 squared is 9. It equals to AB squared, AB is 1, y plus 1. AB squared is 1 plus 1 squared, plus BC squared. BC is x plus 1, so BC squared is x plus 1 squared. So in conclusion, we found out that according to equation number 4, 9 equals to y plus 1 square plus x plus 1 square. Here we open the brackets on both on this side of equation number 4, and we found out that y plus 1 square equals to y square plus 2y plus 1, and x plus 1 square equals to x square plus 2x plus 1, and it equals to 9. But according to equation number 3, we know that y equals to 1 over x. What does it mean? It means that we can substitute y by 1 over x. We did it, and we got that y squared is 1 over x squared, plus 2y is plus 2 times 1 over x, plus 1 equals to x squared plus 2x plus 1. Here we organized the expressions in a different order, and we got that x squared plus 1 over x squared plus 2 plus 2x plus 2 over x equals to 9. In the brackets, the expression in the brackets is equal to x plus 1 over x squared. And here we took 2 as a common factor out of those two expressions, and inside the brackets we left with x plus 1 over x minus 9 equals to 0. Then we defined t as x plus 1 over x, that is to say, according to our definition, t equals to x plus 1 over x, and we substituted x plus 1 over x in equation number 4 by t, and we got here t squared plus 2t minus 9 equals to 0. So we have here a quadratic equation with the missing variable that is t, and the general formula for a quadratic equation is ax squared plus bx plus c equals to 0. Here a, b, and c are the coefficients of the quadratic equation, and x is the variable that we are looking for, and we will find out the value of x according to the following formula, that x equals to minus b plus minus square root of b squared minus 4 times ac over 2a. And in our specific quadratic equation, t squared plus 2t minus 9 equals to 0. First of all, the variable that we are looking for is t, so x equals to t. The coefficient a equals to 1, the coefficient b equals to 2, and the coefficient c equals to minus 9. So we put the data inside the formula for x, and we found out that t equals to minus b, b is 2, so minus b is minus 2, plus minus square root of b squared. b is 2, so b squared is 2 squared, 2 squared is 4. Minus 4 times ac, a is 1, c is 1, c is minus 9, so it is minus 4 times minus 9 over 2. So t equals to minus 2 plus minus, minus 4 times minus 9 is 36. 36 plus 4 is 40. So inside the root we have only left with 40. So in conclusion, we found that out that t equals to minus 2 plus minus square root of 40 over 2. We know that 40 is 10 times 4. And the square root of 4 is 2. So in conclusion, we found out that t equals to minus 2 plus minus 2 times square root of 10 over 2. Here, minus 2 over 2 is minus 1, and 2 over 2 is 1. So in conclusion, we found out that t equals to minus 1 plus minus square root of 10. So here we have two solutions that are possible for t. The first solution is t equals to minus 1 plus square root of 10, and the second solution is t equals to minus 1 minus square root of 10. We focused on the second solution. We know that t equals to x plus 1 over x. That is to say, t is the length of the side of the triangle, and the length is a positive number. If x is positive number, then x plus 1 over x must be also positive number. So in this side of the equation we have positive number, but in the other side of the equation we have the expressions of minus 1 minus square root of 10, that is a negative number, and a positive number can never be equal to a negative number, so we got to a contradiction. Therefore this solution is incorrect solution. We cancel the solution, and we left only with the solution that t equals to minus 1 plus square root of 10. But t, according to our definition, equals to x plus 1 over x. Here we multiplied x by x and then we divided by x in order to have a common factor with 1 over x. And we got that x squared plus 1 over x equals to square root of 10 minus 1. Here we multiplied this equation by x and we got that x squared plus 1 equals to square root of 10 minus 1 times x. Here we subtracted square root of 10 minus 1 times x from this equation and we found out that x squared minus square root of 10 minus 1 times x plus 1 equals to 0. So we got here a quadratic equation, and the general formula for a quadratic equation is x equals to minus b plus minus square root of b squared minus 4 times ac over 2a. In our specific quadratic equation, a equals to 1, b equals to minus square root of 10 minus 1, and c equals to 1. So we put the data inside the general formula for x in order to find out the value of x, and we found out that x equals to minus b, b equals to this expression, so minus and minus is plus, and we left only with square root of 10 minus 1 plus minus b square. B square is square root of 10 minus 1 square minus 4 times ac. A equals to 1, c equals to 1, so minus 4 times ac is minus 4, all divided by 2a. A is 1, 2 times 1 is 2, so in the denominator we have only 2. So we got that x equals to square root of 10 minus 1 plus minus square root of, we did the calculation for square root of 10 minus 1 square, according to the formula that a minus b square equals to a square plus b square minus 2 times ab. And we found out that a square is square root of 10 square is 10, plus b square is 1 square is 1, minus 2 times square root of 10, minus 4 over 2. So x equals to square root of 10 minus 1 plus minus 10 plus 1 is 11, 11 minus 4 is 7. So in conclusion, we found out inside the root, what is left inside the root is 7 minus 2 times square root of 10, all divided by 2. Then we focused on the expression that is inside the root, and we found out what is the value of 7 minus 2 times square root of 10. We actually presented the expression 7 minus 2 times square root of 10 in a different manner. 7 is 5 plus 2, and we have also 2 times square root of 10, but square root of 10 is square root of 5 times square root of 2, so we substituted square root of 10 by square root of 5 times square root of 2. So in conclusion, we found out that 7 minus 2 times square root of 10 equals to 5 plus 2 minus 2 times square root of 5 times square root of 2. But we know that 5 is square root of 5 square, 2 is square root of 2 square, and also it is minus 2 times square root of 5 times square root of 2. So this expression, square root of 5 square plus square root of 2 square minus 2 times square root of 5 times square root of 2, is very similar to the algebraic identity that a square plus b square minus 2 times ab equals to a minus b square. That is to say, we can substitute this expression by a minus b square, when a equals to square root of 5 and b equals to square root of 2. So this expression equals to square root of 5 minus square root of 2 square, according to the algebraic identity that I mentioned. And so we can substitute 7 minus 2 times square root of 10 by square root of 5 minus square root of 2 squared. So we did it, and we got that x equals to square root of 10 minus 1 plus minus. And we repeat again, we substituted 7 minus 2 times square root of 10 by square root of 5 minus square root of 2 squared, all divided by 2. But we have root and square, and the square cancels the root, and we left only with square root of 5 minus square root of 2. So in conclusion, we found out that x equals to square root of 10 minus 1 plus minus square root of 5 minus square root of 2 over 2. So we have here two solutions that are possible. We define the first solution as x1 and the second solution as x2. The first solution is x1 equals to square root of 10 minus 1 plus square root of 5 minus square root of 2 over 2. And the second solution is x2 equals to square root of 10 minus 1 minus square root of 5 minus square root of 2 over 2. So you can see that the difference between x1 and x2 is with this. Here we have the sign plus, and here we have the sign of minus. So we continued with this x1, and x1 equals to square root of 2 minus 1 plus square root of 5 minus 2 over 2. We open the bracket here, we got this expression. Then we substituted square root of 2 by square root of 5 times square root of 2. Again, square root of 10 equals to square root of 5 times square root of 2 minus 1 plus square root of 5 minus square root of 2 over 2. So x1 equals to, we took square root of 5 as a common factor from this expression, and inside the brackets we left with square root of 2 plus 1 minus square root of 2 plus 1. Then we took square root of 2 plus 1 as a common factor out of this expression, and we found out that x1 equals to square root of 2 plus 1 times square root of 5 minus 1 over 2. So we finished with x1. Then we did the same process for x2. Here x2 equals to square root of 10 minus 1 minus square root of 5 minus square root of 2 over 2. We substituted square root of 10 by square root of 5 times square root of 2 minus 1 minus square root of 5 plus square root of 2 over 2. So x2 equals, we took here square root of 5 as a common factor, and inside the brackets we have square root of 2 minus 1 plus square root of 2 minus 1. Here we took square root of 2 minus 1 as a common factor out of this expression, and we found out that x2 equals to square root of 2 minus 1 was taken as a common factor, and inside the brackets we left with square root of 5 plus 1 over 2. So according to what we found out, that x2 equals to square root of 2 minus 1 times square root of 5 plus 1 over 2, and x1 equals to square root of 1 plus 1 times square root of 5 minus 1 over 2. Then we multiplied x1 by x2. So this is the value of x1, this is the value of x2, and we multiplied x1 by x2. We got this expression. Then we organized this expression in a different order, and we got that x1 times x2 equals to square root of 2 plus 1 times square root of 2 minus 1 times square root of 5 plus 1 times square root of 5 minus 1, all divided by 2 times 2 is 4. And we solved, we got the values of those two expressions according to the algebraic identity that a plus b times a minus b equals to a squared minus b squared. And we found out the value of square root of 2 plus 1 times square root of 2 minus 1 according to this algebraic identity. Here a equals to square root of 2 and b equals to 1. And we know that this expression, square root of 2 plus 1 times square root of 2 minus 1, equals to a squared minus b squared. So a equals to square root of 2. Therefore, a squared is square root of 2 squared. Square root of 2 squared is 2. And we also have minus b squared. B equals to 1. B squared is 1 squared. 1 squared is 1. so it is minus b squared is minus 1. So in conclusion, we found out that the value of square root of 2 plus 1 times square root of 2 minus 1 is 2 minus 1. Then we did the same process in square root of 5 plus 1 times square root of 5 minus 1. We calculated the value of this expression according to this algebraic identity. According to this algebraic identity, it equals to a squared minus b squared. Here a equals to square root of 5 and b equals to 1. Therefore, square root of 5, a squared is square root of 5 squared. Square root of 5 squared is 5 minus b squared. b equals to 1. b squared is 1 squared. 1 squared is 1. So it is minus b squared is minus 1. So in conclusion, we found out that square root of 5 plus 1 times square root of 5 minus 1 equals to 5 minus 1, all divided by 4. And in conclusion, we found out that x1 times x2 equals to 2 minus 1 times 5 minus 1 over 4. 2 minus 1 is 1, 5 minus 1 is 4, and 1 times 4 is 4, 4 over 4 is 1. So in conclusion, we found out that x1 times x2 is 1. x1 times x2 is 1. What does it mean? If x1 times x2 is 1, it means that x1 is the inverse number of x2, and x2 is the inverse number of x1. Okay? But according to equation number 3, we have already found out that x times y equals to 1. And we have two solutions that are possible. The first solution is x1, y1, x, that is to say x equals to x1 and y equals to y1. And the second solution that is possible is x2, y2, that is to say x equals to x2 and y equals to y2. So we put the first solution inside the question number 3, and we found out that x1 times y1 equals to 1. What does this expression mean? It means that y1 is the inverse number of x1. Okay, whenever the multiplication of two numbers is equals to 1, it means that the two expressions are the inverse numbers of each other. So we can say that y1 is the inverse number of x1 according to this equation number 3. x1 times y1 equals to 1. But we have already found out that x2 is the inverse number of x1. Okay, but any number has only one inverse number. And because of the fact that x1 has only one inverse number, what does it mean? It means that y1 equals to x2. Okay? y1 equals to x2. And we did the same process for the second solution. The second solution is x2, y2, so we put the second solution inside this equation that xy equals to 1. xy equals to 1, it means that x equals to x2 and y equals to y2. That is to say, x2 times y2 equals to 1. What does this equation number 3 means? It means that y2 is the inverse numbers of x2. Okay, y2 is the inverse number of x2, but we already found out that x1 is the inverse number of x2. Okay, and we know that x2 has only one inverse number. That is to say, if we have two numbers that are the inverse number of x2, it means that they are equal to each other. That is to say, y2 equals to x1. And we have already found out that y1 equals to x2. And now it is very simple to find out the solution to the problem. The first solution to for x and y is that the first solution is x equals to x1 and y equals to y1. x1 is square root of 2 plus 1 over square root times square root of 5 minus 1 over 2. And we have already found out that y1 equals to x2. So this expression is square root of 2 minus 1 times square root of 5 plus 2 over 2 is actually x2. And because of the fact that x2 equals to y1, it is actually y1 also. And the second solution is x2, y2. x2, according to what we have already found out, is square root of 2 minus 1 times square root of 5 plus 1 over 2. And according to what we have already found out, y2 equals to x1. Okay, so this expression, square root of 2 minus 1 times square root of 5 plus 1 over 2, it is actually x1. And it's also y2 because of the fact that y2 equals to x1. So those are the two solutions for the question, x1, x1, and x2, y2. Okay, thank you very much.